Hello everyone, I am Mr. Stewart and today we will be learning how to compare fractions. First, let's go over our goals in meeting this 4th grade standard. We will learn how to compare fractions with different numerators and denominators by creating common denominators and numerators, comparing fractions to a benchmark like 1/2, understanding that valid comparisons can only be made once the fraction wholes are the same. That would be in the denominator. Then be able to use symbols greater than, equals to, or less than to show comparison between fractions. Now for some review. First, let's go over the definition of a fraction. A fraction has two parts, the numerator, the number on top of the line, and the denominator, the number below the line. The numerator is the number of parts there are, and the denominator is how many parts it takes to make a whole. So this is 1/2, or 1 of 2. 2 parts are needed to make a whole in this fraction, and there are 1 of them. So that's why we call this 1/2, because 1 is half of 2. Another great tool to use when comparing fractions is comparing fractions to a benchmark. Let's use the 1/2 benchmark to compare the fractions 3/7 and 5/9. Comparing it to 1/2, we know that 3/7 is less than 1/2 and 5/9 is more than 1/2. We know that because 3 is less than 1/2 of 7 and 5 is more than 1/2 of 9. Through that reasoning, we can now easily determine that 5/9 is greater than 3/7. And last but not least, I want to make sure that we understand that equivalent fractions are fractions that, while they may differ in numerator and denominator, are still equal. For example, 1/2, if you multiply that by 2 over 2, we get the same fraction, or equivalent fraction, of 2/4. 2/4 is the exact same value as 1/2. Let's practice one more time. If we take the fraction 3/6 and let's multiply this one by 3 over 3, we get 9 over 18, which is still also equivalent to 1/2, but is still equivalent to 3/6 and 2/4. Now let's practice comparing fractions by creating common denominators. Now, we can deduce that 2/3 is probably smaller than 3/4, but we can't make a valid comparison, right, without making the denominators the same. Okay, so we have 2 out of 3 in that box and 3 out of 4 in this box. But we can't make a valid comparison unless the denominators are the same. So what is a common denominator of 3 and 4? Well, what's 3 times 4? Isn't it 12? I think 12 would be a great common denominator to have for this comparison. Alright, now we have broken down our 2/3 and 3/4 into 12 parts each, 12 equal parts. So we have 4 sections per third here and 3 sections per fourth, so each is 12. Now we can make a valid comparison between 2/3 and 3/4. And I think we can see that this line right here, the second third, is not as far as the third fourth. Alright, now that we've practiced drawing diagrams to compare fractions with common denominators, let's hop over to the right side of the screen and practice comparing 5/11 to 7/13. It is easy to see that 5 out of 11 is close to 1/2 and 7 out of 13 is also close to 1/2. But since 11 and 13 are odd numbers, their halves are not whole. So let's use a number line to compare these fractions. This first number line will be the one to represent 5/11. So we'll start this at 0, go all the way to 11. This is about our halfway point, which is 5 1/2, 5.5, which means our 5 would be about right here on the number line. Now let's do that for 7/13. Got 0 here, going all the way to 13, halfway point, about right there. And half of 13 is 6.5. And we know that 7 is above 6.5, so that would be right there. So right here, we are using a benchmark of a half, and we can see that, because of the rule, 7/13 must be greater than 5/11 because it is greater than half, and 5/11 is not. Alright, to continue with comparing fractions with benchmarks, let's compare 7/8 to 5/6. Now, both of these fractions are one unit fraction away from a whole. So, on this number line, if we go from 0 to 1, this is how we can easily compare these two fractions. So, it takes 8 unit fractions to make a whole in this fraction, and 6 unit fractions to make a whole in this fraction. We can easily determine that the parts are smaller in 7/8 than they are in 6/8 because it takes more of them to make a whole. So, if we make 8, 1, 2, 3, 4, 5, 6, 7, 8, that's going to represent 7/8. We fall right here because there are 7 of them. Now, if we switch colors here to blue to represent 5/6 and split it into 5 sections, 1, 2, 3, 4, 5, and then there is the 6th one at 1, we can see that we fall about right here because the parts are bigger, and if we have one less of them, then we are going to be farther away from 1, which means 7/8 must be bigger than 5/6. Next, let's see if we can compare 2/12 to 5/16 with using the benchmark of 1/4. Now would be a great point to pause the video and then start it up again once you're ready for the explanation. Alright, we're all set up and ready to go. So if we are using the benchmark of 1/4, we know that 1/4 of 12 is 3, and we know that 1/4 of 16 is 4. So if we have 2/12, we know that is below 1/4, and 5/16 is above 1/4 right there. So, using the benchmark of 1/4, we can easily determine that 5/16 is greater than 2/12. Now that we have learned how to compare fractions with the benchmarks of 1, 1/2, and 1/4, it is time for some challenge questions. Feel free to pause the video and wait for my explanation after you have attempted to solve these 3 fraction comparisons. Alright, I hope you guys fared okay, and I hope this is what you guys came up with. I'll start with 9/40 compared to 12/44. Alright, so using the benchmark of 1/4, I hope you guys figured that out, because they're both very close to 1/4. We know that 9/40 is less than 1/4, because 10/40 is 1/4. And then a fourth of 44 is 11, so 12/44 is more than 1/4. So just by comparing these two fractions to 1/4, we can determine that 12/44 must be larger than 9/40. Without having to find a common denominator, because that might be hard and require a calculator because these numbers are larger than smaller ones. If we look at this next one, we can see that we will be using the benchmark of 1/2 and comparing 13/25 to 18/35. We know that half of 25 is 12.5 or 12.5, and that half of 35 is 17.5 or 17.5. So 13 is 0.5 bigger than a half, which falls right here on the number line, about, and that 18 falls just over halfway to 35. So now we run into the dilemma of which is bigger. Well, 25ths or 35ths, which is bigger? Each part of 25th, each unit fraction, 1/25, is larger than 1/35. So if we have 0.5 more of a 25th than 0.5 of a 35th, then we know that 13/25 must be larger than 18/35. In this last one here, all we are doing is using the benchmark of 1 to compare 51 53rds to 65 67ths. So all we do here, they are both 2 unit fractions away from a whole, and because 51 53rds has bigger parts than 65 67ths, we know that if there's 2 less of these and that they are bigger, 65 67ths must be larger because they are missing less. So right here we look at the number line, 65 67ths is closer to 1 than 51 53rds.